All right, guys, welcome to the Work to the Next webinar with Gerald Becker from Quanergy, a LiDAR company. One of the really interesting one, done a really cool integration to network optics that gives you a lot of capabilities that you're not going to get from your standard kind of camera implementations or even other sensor implementations. So Gerald, you want to introduce yourself, and we'll get started during the presentation, guys. If you have any questions or you want to chat, there's a chat window and there's a question section. Ask your questions there. I'll interrupt Gerald whenever it's convenient to ask him the question you ask. And then after the show, we're going to be putting it up on our YouTube channel, and it'll be available there for consumption. So Gerald, over to you.
Thanks a lot, brother. I appreciate you having us this week. Name is Gerald Becker. For those of you I haven't worked with, I head up strategic alliances and market development for Quanergy globally. I specifically handle anything related to projects in the physical security industry. Today, we're going to be showing you something quite different than you guys may be accustomed to seeing in the security market. Now, we've been around for quite some time. But we do consider ourselves, or we are the market leader for 3D LiDAR and perception software. So you guys are going to see a lot of cool stuff here today, and especially what we're going to show you inside the NX, which I'm going to show you a little bit later. Now, I'm going to go ahead and jump right into the slides. So first and foremost, I'm going to do a quick company background before I get into the fun stuff. So about Quanergy, we're a US-based company founded in 2012. We're based in the Valley, Silicon Valley. LiDAR sensors and 3D perception software. I'm going to explain what perception software means in a moment. Now, we serve various markets. Our primary markets are the IoT markets. Specifically today, we're heavily focused on the physical security applications and use cases, and now see the future of automotive markets, which everybody pretty much knows LiDAR for. We have quite a few customers around the world, various markets, and quite a few partners across different market sectors, from industrial, automotive, physical security, drones, and several other markets that we cater to, such as AVGs and other markets as well. Now, we have quite a few patents already issued, a couple pending, and we have about approximately 125 employees globally. We are a global company. We cover every major market around the world. And last but not least, we're NYC, a publicly traded company. Now, let's get into the product. Now, what is this, and what are we going to be talking about today? So, Quanergy manufactures 3D LiDAR sensors. Now, the difference between our sensor and a lot of the other IoT sensors that you guys may be accustomed to is that we're able to do 3D object detection, 3D tracking and classification, with pinpoint accuracy. I'm talking about centimeter level, right? We're also able to do 3D position, direction, and speed of motion. And then one of the bigger components of our solution is that we're able to fuse our sensors together to create one world. So literally, if you have enough sensors sprinkled at your facilities, you could literally be able to catch a threat as they break through the window, run down the hallway, go down another corridor, break into the safe, and jump out of the window. We're able to hand off from one sensor to the next and uniquely be able to track that object ID all throughout that journey that they're taking inside the property, interior or exterior. Now, we're also able to communicate to cameras directly, or our preference is through the VMS to be able to do the event to action workflow, salute a queue, trigger bookmark, recording, whatever it may be from there. Now, as far as sensors goes, we have quite a few different sensors as far as indoor, outdoor, IP rating, PoE plus, non-PoE, the different types of sensors, 2D or 3D, which we'll talk about here momentarily. So how does this all work? So you see me on my camera. I'm going to show you guys. I have a sensor. This is our flagship sensor. This is an MQ8 sensor, and it's a PoE device. You connect your RJ45 connector directly into it. It's like a camera. Once you power the device up, inside of it, there's a turret with lasers stacked on top of each other and pointing in various angles. And what it's doing, it spins really fast, about 10 hertz. It's is the frame rate that we're doing with the unit. And when the laser starts spinning in circles, it's shooting them into an open space. And what's happening is every time a laser hits an object, it leaves a point and it bounces back to the sensor and it detects how long it took to hit that object and to bounce back. Now we're using time of flight as unit measurement, so we know light is constant. We can measure speed of light, and we're leaving about 1.3 million points in a 3D space. And so we don't see like cameras do. So one of the biggest things that's different from us and cameras is that we can't read sound, we can't read color, we can't see biometric features. Everything that we see looks like a silhouette. So in that point cloud with all those different points, what we see is very similar to what many of you have seen, like my favorite movie of all time. When Neo looks down the hall and he sees the ones and zeros dropping from the sky, that's exactly how we see. But instead of ones and zeros, it's actually little points. So we're able to understand, is it a person? Is it a vehicle? Or is it an unclassified object like an animal or foliage moving around like trees? From there, we have a layer, a software layer called perception. The easiest way to understand perception software is that it's very much like the camera analytic that you would install either on a server or on a camera itself. So perception is our analytic to our LiDAR sensor. Our perception software, which is our analytic, tells us, is it a person? Is it a vehicle? It gives you position, direction, and speed, which we then pass directly to Network Optix VMS NX to then ingest into the VMS for any type of events that occur within our software. I'm going to show you that here in a bit. Now, from a top-down view, this is what our sensor looks like when it starts to shoot a laser out. So it bounces, it shoots them real fast, and then it creates a 360 3D virtual wall that you can see. From there, it's shooting them all the way out up to 100 meters out. So we'll be able to detect an object at 100 meters, but we continuously detect, track, and classify at the 70-meter radius mark. That's 70 meters from the center of the sensor out. So you could go in any direction 70 meters. So about 140 meters of continuous object detection, tracking, and classification. Now, once again, we don't see like cameras do. So what you see here is when the LiDAR hits an object sees it, or I'm sorry, the laser bounces back from the object, and this is what we see. We don't see like cameras do. We see everything in like silhouettes. They look like shadows, if you will, walking around inside of our software. So you'll be able to make and understand what objects look like once you've seen the perception running within your deployments in your lab or in your facilities long enough. Now, this is where it really starts to get interesting. For those of you who haven't seen LiDAR in action, and I'm going to compare it to cameras. So what you'll see here on the bottom right-hand corner is what a camera sees mounted on a vehicle driving downtown San Francisco. As you can see, the buildings passing by as we drive back past them. Cool deal. Now, the difference between what LiDAR sees and what a camera sees is that with a camera, you're limited to only what the optics can see. You can only see what's in front of the imager and what's in front of the sensor itself. You can't see to the sides, to the top, to the bottom, or behind. I know there's other types of cameras out there, but this particular camera, you're only limited to what the camera can see. But in the bigger part of the scene is what's being captured with LiDAR. So in this scene, if I wanted to, I could literally pause on this screen. I could jump on a building about 2 to 3 blocks down the street, jump on it, stand on it virtually, then turn the image around, and I could see myself driving towards the building that I'm standing on 3 blocks down the street. Just so you guys all have a frame of context of what I mean, I'm going to jump ahead real quick and just give you a sneak peek of what I'm going to present here momentarily. But this is my office. This is a top-down view of my office. You can see I'm doing jumping jacks here in my seat. 1, 2, 3. So you can see I'm waving right there. Now, as I mentioned in that previous slide, I'm going to flip this on its side. I then spin this around. I'm now looking at myself, looking at my screen, but the sensor is behind me. So as you can understand from what I meant on that previous slide, you can look at it from different vantage points that you've just never been able to do with 2D technologies in that regard. So let's jump back to the slides. Now I'm going to talk a little bit about the key differences between some of the technologies that are out there. Now I'm not going to pick on cameras too much because cameras help us see. We can't see. Cameras, we augment camera deployments. Well, we need to understand that Gerald's wearing a button-up shirt, or he's got a shaved head, he's got glass, or whatever. That's what cameras help us see. But there's some key differences between some of the other legacy tech that's out there, be it underground cable, fiber on a fence, a microwave radar, so on and so forth. Now, some of the key differences is, yeah, and I'm talking about apples to apples. I'm not talking about multi-million-dollar military-grade radar solutions that go on a military ship or on a plane, right? But when it's apples to apples in this regard, you see sensing dimension, we do a 3D, comparatively 1D with the radars that we're going up against, and then range, we're about head-to-head with them in that regard. Range accuracies, where we then start to pull ahead. Now, our sensors are very accurate, down to centimeters, versus going to be feet and or meters depending on the radar you go with, but I'm talking once again apples to apples comparatively on price point in the market. Object classification, field of view, we do full 360, but we also got a very high angular field of view where we're doing about 12.4 degrees in a vertical field of view that you're able to capture, and that's going in full 360. So you're going to get very, very wide field of view and very long range. Now, we do our own object classification. As I mentioned, with our perception software, Qortex, we're able to decipher, is it a person, is it a vehicle, or unclassified objects such as foliage, animals that create nuisance alarms. Now, where we do potentially fall behind is heavy, dense fog. And I'm seeing about 50 plus meters out from the center of the sensor out, you'll see a decline of the sensor laser. But typically when we put this, like say on a cruise line for a manned overboard application, we'll put about 5 to 8 or 10 sensors on each side of the boat, and they fuse together, overlap with one another, so you'll never lose an object. God forbid if someone falls off the side of the boat, we'll be able to event and trigger alarm a notification to someone on the boat to, hey, someone's fallen off the side. Now, we excel very well at night. We're creating our own night vision. We're shooting our own lasers, so we're able to create a complete digital twin of an environment, so we have no issues in pitch dark environments. Now, where we do fall behind, we absolutely do not do well, is that we don't read sign, we don't see color, and we can't make out biometric features. That's where we heavily rely on cameras, and that's where we work very well. When we trigger an event, we then point the camera and say, hey, keep track of this person in the field of view. They're the perpetrator, good actor, or bad actor in the scene. Now, as far as our solutions go, yeah, go for it.
Gerald, I just had one question for you. So like, obviously on the image you showed us, right, you're painting a silhouette of somebody. Is there such a thing as like a resolution for LiDAR, or you know, like the level of distance between the reads or anything like that?
Yeah, absolutely. So our sensors are obviously very high resolution in the sense that we're able to actually create a very dense point cloud, right? So in essence, we're doing about 1.3 million points in the 3D space, and that's what's giving you the understanding and be able to capture the density and be able to do volumetric sensing in that environment, right? So that's how we're able to actually be able to understand what the objects look like in the scene. So was any other type
1.3 million points in a point field. Do the points they stay consistent no matter the size of the field you're looking at? And so basically, the larger the area you're looking at with one sensor, the less kind of resolution you're going to have on what's going on versus if you, let's say you use a LiDAR like in your office right now, you're going to get a lot more detail from it. Or is it, I'm trying to understand it for like normal human beings. So like,
yeah, so when the lasers shoot out, the lasers will obviously get a little bit bigger in the field of view in a sense, but when they start to spread out, that's why we only go about 70 meters radius in the sensor. So
okay.
once the lasers shoot out, it starts to obviously spread apart, right? And if an object goes in between, we could potentially miss that object, but that's why we rate our sensors to be 140 meters of continuous object tracking and classification.
Okay, so like that's basically like the field of view for a sensor is, it's just a dependable field of view is going to be 70 meter radius.
Absolutely.
Right? Okay, cool.
So a couple key things to also pull away is that, out of most sensors available in the LiDAR space, we're NDA compliant. So I know that's important to a lot of us here in North America. In Europe, GDPR compliant come in as far as privacy concerns when you're dealing with legal or visibility issues in outdoor environments or even employee areas. We're not capturing any sort of identifiable information on people. So there's zero PII risk to that in that degree. Now, this is an eye-safe Class 1 laser. It's 905 nanometer laser, so it's not harmful to the human eye. So Some key metrics on the sensor is it's 140 meters in max range, as we just spoke about. It's a 360 horizontal field of view, vertical of 12.4 degrees. It's PoE plus. Takes about 18 watts of nominal power, continuous nominal power for the unit to run. IP67 rated. And then last but not least, 60,000 hours of mean time before failure is what we estimate is about just shy of 7 years. But we've had these out for a lot longer and more extreme environments. So one of our clients in the Middle East, up to 140-degree weather, sandstorms, beating down on it, running for 5-6+ years out there with no issue in that regard. The benefits of integrating Quanergy with NX is that this actually came from one of our clients that tested extensively our solution. They got over 95% drop in false alarms, a large coverage area, and accuracy, bar none, that trumps a lot of other type of technologies that are out there. Continuous object tracking, you're going to see that here in a second, which is obviously something really cool. When it's really difficult to do with other IoT sensors, we do it very well. We're going to track that full chain of custody, cradle to grave. It works great in various types of harsh environments. You can see in some of the demos I'm going to show you here in a second. And we get tested all the time. You know, people try to put obstructions in front of the sensor. They try to shoot other laser jamming devices. We're not susceptible to any of those type of breaches or trying to break into the sensor in that regard. We also have a significant lower TCO than server-based video analytics, just because of the compute to server type of cost versus how we deploy with our sensors. Last but not least, 100% no PII risk in that regard. Key metrics on our perception software Qortex, which you're going to see in a second. When it comes to counting, we do 95% people counting accuracy. We can track about 600+ objects in the scene. And then once again, 140 meters continuous tracking, centimeter level accuracy. So let's go into a quick demo of Qortex, and then we'll jump back to the slides here momentarily. All right, so as I showed you earlier, this is a top-down view of my home office. So I'm already logged into the system. I've already authenticated to Qortex, and what you're seeing here is basically a 3D digital twin of my environment. The sensor's off to the side of my refrigerator here behind me. And what I'm going to show you is how we're able to create 3D zones. Within Qortex, we have the concept of event zones, exclusion zones, and inclusion zones. An inclusion zone basically means is that I want to create an area that I want to include all this box, and in that inclusion zone, I want to create event zones that can eliminate, you know, us having to look at different areas that we just don't care about. Maybe it's a highway. You don't care about cars going back and forth. You only care about the perimeter fence line. But within that, you can also create exclusion zones. So let's go ahead and create an exclusion zone. Maybe I got an area right here. There's trees all over the perimeter right here that are swaying back and forth, that are creating all kinds of false alarms inside my system that is just creating havoc, right? Or maybe this is a correctional facility, right? And you want to create a barrier for maybe the barbed wire, or maybe that first detection zone, which is basically the exterior fence line. And what you see here is basically I've now created an exclusion zone for trees. I don't want to see when trees are swaying side to side. I don't care about that. Those are nuisance alarms. I only care about event zones inside of the trigger areas, as you can see right here. So I'm going to go ahead and disable this for now. And then I'm going to look at the actual inclusion event zones. So in here, I have 2 event zones. So let me minimize that and bring up my event zones. As you can see right here, these 2 event zones are 3D polygon shapes. I could create as many to my heart's content within the 3D space. Now, what you can see here is these 3D zones are the event zones that are going to trigger alarm events into NX here momentarily. In these event zones, I can set up how high I want the min Z, the max height, so I can decrease the bottom, I can increase the top to my heart's content. And I can also stack these on top of each other. So if you want to create a very dynamic scene where you stack different event zones on top of one another, where maybe if it's a corrections facility, the first fence line is your first alarm, it's a soft alarm. The second one's your barbed wire, which gets guys out with guns or whatever. The third one's a helicopter zooming in. You could create multiple different barriers in different 3D zones inside of Qortex. Now, I'm going to jump back into the slides. And then from there, I'm going to start going into some of the use cases that we have. So first and foremost, how does this all come together? This is our architecture flow at a high level. Our sensors connect directly to our Qortex server. This is an Ubuntu instance. It's very lightweight, does not require GPUs, and this can be virtualized inside your VM environment. From there, an optional client can be installed. This could be Windows or Linux. And from there, you can configure, tune, set up however you see fit your system as far as the 3D zones within the environment that you're trying to track. From there, we pass metadata directly to the VMS, zone list, object list, state list, which then creates the event to action workflow, triggers the if this, then that. Send a camera over here, bookmark an event, give me a pop-up or sound an alert sound that's going to notify security personnel. As far as the markets that we cater to, we have quite a few markets, but these are some of the biggest markets that we're dealing with right now. In airports, bread and butter PIDs, perimeter intrusion detection. We're monitoring fence lines. We're doing queue line analysis. We're doing man traps where people are coming in from TSA, going to a secured area, going to the tarmacs. We're able to track where the people are going. Smart cities, we're automating lights, connecting to light controls, turn them yellow, then red, depending on the flow of traffic and pedestrian for pedestrian safety, collision avoidance. Retail, we're tracking behavior inside retail, be it for consumer analytics or maybe for loss prevention in that regard. We could track when there's anomalous behavior in the parking lot. Say someone's coming in a big car with 10 people, that can then trigger the alarm event to then start tracking people inside the retail setting, move cameras around. Or from an analytic perspective, if you use if any of your end users use analytics or BI, you track journey, dwell, intent, footfall, heat maps, all that kind of stuff. Now, I do come back to this critical infrastructure, utilities, data centers, borders, solar, ports. Those are all bread and butter use cases. Perimeter intrusion detection. By far, our sensor is the most accurate sensor for tracking objects, for intrusions and tracking coming in and out, depending if it's an intrusion in for approach detection or someone potentially escaping, say for a correctional facility. And corporate building has been picking up a lot for us as well, where we're actually monitoring density, the crowds inside of office space, counting office space utilization. If nobody's on the second, third, fourth, or floor, let's turn off lights, or let's maybe decrease the amount of HVAC being pumped into those floors to decrease OpEx expenditures in those facilities. Last but not least, public venues. A lot of the same things I just mentioned. We're doing stadiums, casinos, theme parks, open air concert areas, where we're monitoring and tracking the journey that people are taking, flow management, where people are going, where they're coming from, and automating different workflows inside the VMS. So first video, first use case. This is outside of the VMS. I'm going to show you this inside of NX here momentarily, but I'm going to show you how we work directly with cameras. So on the left is Qortex. This is a top-down view of Qortex tracking people at a trade show a while back. Inside of this perception cloud, you see that there's a zone. This guy with his hands in his pockets breached this yellow zone earlier in the video. Because he breached that zone, we're continuously sending location data directly to the camera to keep tracking Mr. Good Guy or Bad Guy in the field of view. Now I want to pause right about here. This is where cameras get confused. You guys know this. I'm sure many of you guys have seen this in deployment when you do traditional PTZ tracking and you have another object that gets in front of the other person. It doesn't know, do I track the person in the foreground or in the background? I don't know. Not with us. We continue to send location data directly to the camera to keep tracking that individual in the field of view of the sensor until we decide to either click on another object ID or inside of NX, you push another preset, move to another, or move the joystick around to then move the camera to another object of interest. Similarly, this is a more dense environment. This is a museum that we're tracking potential theft of priceless artifacts or paintings. You're seeing we're tracking hundreds and hundreds of people. We've created 3D zones. Let's say it's behind, maybe it's tracking a painting or an area that's has a very priceless object. Someone breaches that zone. We then tell the camera to then turn to the right and start tracking that potential threat in zone 1 because someone put their hand over in that zone. Someone leaves that area, then goes back to its home preset and continues to monitor the area throughout the environment. Now, this is where it starts to get fun. Now, I've talked about workflows and I've talked about automation, but what does this all mean? Now, when you start thinking about a large deployment, you have hundreds of cameras and you've got LiDAR sprinkled strategically at corners or in areas where you don't have coverage with your camera, what we're able to do is do automated ID handoff to then track from one sensor to the next. So what I'm going to show you here, there's 2 PTZ cameras, 2 3D zones in Qortex. When I click play, one of our engineers walks into the R&D lab and it triggers the first camera. It starts tracking them inside in 3D down to the centimeter with pinpoint accuracy where that person's going. Momentarily, he's going to jump from event zone number 1 into event zone number 2. It's then going to then trigger the second camera. As you'll see here, when he walks from event zone 1 into event zone 2, second camera takes over. The first camera went back to its home preset. Now the second camera will then continuously track in this environment. Now, if you have enough laser coverage, we'll be able to track. We're shooting lasers all throughout. If cameras can't see the walls, but the laser is still tracking on that person, we're going to tell the camera to stay fixed on this position until that person comes back out. As you can see, he comes back out of the office. We're tracking him again. He's then hidden behind that light right there, but the lasers are still on him. Last but not least, he goes from event zone 2 back into event zone number 1. Second camera goes to its home preset, and the first camera takes over. Now think of this. Large open air perimeter environments. Think of this inside your indoor environments, heavy dense environments where you're tracking objects, how we could automate this handoff from one sensor to the next to make your security guys, your surveillance operators more efficient in operating in their environments. Now, let's start talking about use cases. So first use case, I'm going to show you how we do oil and gas. This is a big oil and gas facility that we're deploying. We tied into Google's Map API. So this is a pretty straightforward Google Map integration that we did. On the right-hand side is Qortex. There's 4 sensors here. You can tell by the halos, 1, 2, 3, and 4. Now, what's important here is how we're going to minimize the false alarms. Once again, bringing value to the system and not getting alerted when a bird's flying in or there's a car driving by or people are interacting inside of the property. So you're going to see a car moving around and people walking around. And we don't care what's beyond 3 meters beyond each side of the fence line. So you can see right here, we don't care about this car. We only care about 3 meters on each side of the fence. Now you can see the 1, 4, 2, and 10 objects are maintaining the same object ID from one sensor to the next, all the way up and down the fence line throughout the journey. We maintain the same unique object IDs all throughout. You'll see different objects jump in and out. Those are employees coming in and out of the field of view. As you can see, we're accurately tracking from one sensor to the next, all throughout that environment. Same thing for utilities. Think of critical infrastructure. Think of utilities, substations. Same thing inside this environment. We don't want people breaching, hacking in, stealing copper, stealing any potential objects inside the property. In this regard, if someone breaches this area, we automatically take over the camera and start zooming, panning, and we salute a cue to the camera. Once again, this can also be done directly through NX. We prefer inside the VMS, but as you can see, this is just how we talk directly to the camera in this environment. One more to show you. This is another PIDs for corrections. As I mentioned, we could create 3D object zones. You could create the exterior soft alarm. You got that barbed wire in the middle, and then you got the interior fence line that triggers all kinds of different events. In this environment, you see that they're also triggering a third-party drone. We don't do any of that stuff. This is just something they did on their own. Once the alarm, the fence line is triggered, then they start tracking any potential threats up and down the fence line, as you can see right here. Now, this is where we start looking into some of the unique applications as far as what we can do beyond PIDs. We do quite a few applications, and MOB is something that's traversed beyond man overboard. Man overboard is something that's very well known in the cruise line industry as far as a potential cruiser falling off the side of a boat. It happens all the time. But we've been seeing a lot of applications for MOB for enterprise, corporate deployments. We've also seen this at hospitality for resorts. And the way they're using it is basically to track when nuisance alerts are coming out because people are throwing beer bottles or shampoo bottles off the side of the resort that are coming down and hitting other guests, which is a huge insurance liability issue. Also with corporate accounts, we've seen that certain parts of the world, people are things are going bad. They jump over the side of a railway or walkway. They want to know when people are in certain areas. So this all started predominantly for like cruise lines. We're tracking objects falling off the side of a cruise line. This is one of our corporate offices. You can see we're just throwing a dummy off the side of the boat. Very close range and very far range, we're able to detect. But this could be used for everything from venues where you're tracking people jumping into fountain areas, very large open areas, railways, walkways, tunnels, stuff like that. It can be deployed for all types of applications. We're also doing this for rooftop security. Oh, go ahead.
Yeah, Gerald, that was, regarding like the stuff that's falling, and then most of these applications that you're showing us are person-based, right? But LiDAR, it seems like, isn't limited necessarily to people, right? Autonomous robotics, things like that, you could also track and keep an eye on, right? So I guess
Absolutely.
my question is what, like, how would you define, is there already defined objects in it, or is there a way for you to kind of say that's this, right? Does that make
Absolutely.
sense?
So it sure does. So inside of Qortex, you can actually create different type of event rules. And I'm getting ahead of myself, but within the event rule, you can then select what you want to do. So I'm going to track and then the type of rules. So, what zone you're tracking. And then from there, you can also select the type of objects. Is it a person? Is it a vehicle? Is it an unclassified object? So you have the capability of tracking different type of objects that are already pre-programmed into our solution to track. So an unclassified object to us could be like a drone robot device walking around in that facility doing security. It can also be a deer or animal coming up to the fence line, or trees and shrubs like that. Vehicles, we also do sub-classification of vehicles, so we can do different types of vehicles to track who's coming onto the property, and obviously humans. So humans is one of our
Yeah.
primary.
So for like the vehicles and stuff like that, I guess you started off just saying this is a vehicle, all right, and then later on, people were like, I need to know if it's a truck or a car or a motorcycle or whatever it is, right?
Yep,
Um, so is it that like you can't define the objects yourself in there? They've got to be defined by the software at the software level, right?
correct. So
But
Cortex
but
is
is it? I guess my question is that is the tendency for this that the longer you guys are around, the more objects are going to be in that kind of library because there are more and more use cases for them.
spot on. So you hit that on the nail, right? So, early on, you've got to look at LiDAR has predominantly been used for the autonomous world, right? Self-driving cars. A lot of it's been tracking the environments as far as what vehicles are going into, right? Going up and down streets, you see a lot of trees, you see vehicles, you see people, and we're already starting to work with third-party analytic companies and bringing in additional hybridized type of approaches where if there's an LPR detection, it could then trigger the vehicle to then marry with the LiDAR tracking to then track in that environment. Or think of like gunshot detection, right? If a gunshot goes off, we can then triangulate and understand who the potential threats that may have occurred in that instance, right? So maybe these three people that are dispersing in different angles are not the guy, but the guy that's just standing there solo may be the guy who's actually committing the crime, and we track where he's going. So to your question, yes, we're going to continue to add additional classifications as we continue to mature in the industry. And as we see fit, as we see it right now, our solution is by far one of the most advanced platforms to be able to track different classifications in the environment, married together with our sensors. We're one of the only LiDAR companies that does both perception and the hardware itself all in-house.
Classification, yeah. On the classification side, is there any sort of neural network or anything on the back end, or is it more like your kind of pre-programmed algorithm, like basically?
Is pre-programmed algorithm. We are moving to AI models in future iterations, but for now, all the algos are pre-programmed with the type of objects that we track.
Based off of like size and general attribute, I guess, yeah. Okay.
Spot on.
My,
Absolutely.
my 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 guess is that you guys are rolling in the AI stuff because now you'll be able to use the data to train it on like specific objects as opposed to like the general ones that everybody. You're kind of following the route of the video, right? We had motion, and then we had, oh, that's a person, right, or an object, right, and then we had cars, and then we had license plates and OCR stuff, and then we had, okay, now this is this type of car that's this color with these type of wheels. You know what I mean? It's getting more and more granular. So I'm assuming you guys are along the same trajectory as video, just you're behind it a little bit because the point cloud LiDAR stuff is newer.
You took the words right out of my mouth. Yeah, it's just the evolution of where we're going to be, right? So, I couldn't have said it best, right? So Analytics started off very basic in the beginning, and I've got a couple of slides to show you the differences of how we're different from 2D to 3D. But yeah, you're spot on that. Absolutely. Couple more use cases. I'm going to jump right into the TCO and different perspective on a solution. So we do obviously rooftop surveillance, catalytic converters, copper. I'm not showing you guys anything new there. Now, with Qortex, we're also able to do counting as well. I did lose my video. I don't know. Are you still there, Tony? Okay, cool. Just making sure. All right. So with Qortex, we're also can do some basic counting, and this is all through a web interface, which we can ingest directly into NX via URL. But I just want to show you, we can also do counting with Qortex. Does some basic people counting, enter and exit into different zones that we create with a 3D zones that we create within Qortex. Now, I do want to talk through some of the differences between how we do it versus cameras. I'm sure you all have seen it with cameras where it's overhead at a trip line, counting in and out. Issue with this is sometimes you may get a 2-for-1. Different lighting environments, which is not an issue with us, is that if sun casts a shadow, you might get a 2-for-1 again. And then plus, cameras dedicated to counting in this regard. It's pointing straight down. You ran your cable directly to that location, and it's only dedicated for that. You can't use it for anything else. This is an outdoor environment where we're doing the exact same thing. We're counting. But in this regard, we're counting up the street, but our sensor's over here, which means you could be right next to your PoE switch, right next to your IDF cabinet, so it limits the amount of installation labor required to install. And plus, in this regard, because we're 3D, you can put it all throughout in this environment. Doesn't mean overhead like we're doing in the previous video, but from here, as I click play, you're gonna see accurate counting. And this venue right here, that you can see it's gonna change colors and create all kinds of dynamic scene, different ambient lighting that could be detrimental to cameras in that regard, but not with us. It's going to change colors. It's going to create shadows on the floor. We see people holding hands shoulder to shoulder, and it's still accurately detecting counting with 95% accurate. Once again, this is just a basic counting application we have within Qortex that we can push directly into NX to also provide a slide for counting. Now, as far as challenges with object tracking from a 2D perspective and a 3D perspective, you guys have seen this before. From 2D, you're going to see one here when I click play. Yes.
Yeah, my cat was coming in here earlier. It's not just you, Gerald.
Okay. I'll have the wife make sure the dog is quiet down up there. Sorry about that, guys. So what you see right here is we're getting a 2-for-1. You see Grandma and Grandpa are giving us one person. Bear with me once.
He wants to talk about LiDAR too.
Yeah, it does. Got a little puppy in the background.
Yeah.
So what we see right here is we get a 2-for-1. 2-for-1 right here at the kiosk as well. So you see this is typically the limitation when you get 2D camera object tracking, is that it can't see behind it, doesn't understand the volumetric sensing environment, right? Now, what we do, I'm going to show you an example. We have 2 sensors right here, and you're going to see people walk up and down towards the entrance and towards the end. And this is a top-down view of Qortex. You're going to see each person's going to come in with a post-it with a unique number on each post-it. And you can see there's going to be about 30 people that walk in this environment. Each person is going to get uniquely identified, uniquely tracked in this 3D zone. So you can see that unlike the previous video where you're getting a 2-for-1, we're not having that issue in this environment. So this is good for Q-line. This is good for tracking and making sure you're actually tracking unique objects when they come in, and you're not, seeing that there's only one person when it's actually 2 or 3 people bunched up in an environment. So this is what I mean by accurate volumetric sensing in 3D to be able to get pinpoint accuracy when every single person comes in, and it matters to track every individual. All right, let's talk about adverse weather. It's raining cats and dogs. I'm gonna bring the volume down because it's pretty loud. And what you see, there's a guy with an umbrella right there. It's raining, it's coming down hard, and this is not creating false alarms within our solution. So normally with other types of applications, you'll get false alarms if it's like computer vision apps, or maybe sometimes a dome will start sensing when it's hidden there, but not with us. You can see very accurate in outdoor environments. As far as snow, On the left-hand side is before we tuned our system. You see we're capturing a lot of the objects falling down. On the right is after we've tuned it. There's a guy sitting right there with his laptop, guy walking around here, and we're not getting any false alarms as far as the snow falling down inside that scene. Now, as far as counting objects in various lighting and adverse lighting conditions, you'll see right here, lights are on, we're turning lights off. We're able to accurately track an object as he's coming in and out of that trigger line, which is counting in the Qortex counting app. So he comes in, he comes out, we count in, we count out. Here's another scene with 2 people coming in. Let me fast forward that a little bit. So there's 2 people in, 2 people out. So as you see, this is probably an environment where you're going to have a very difficult problem trying to do this with other IoT sensors, but not with us. Now, as far as being able to continue to detect, track, and classify very far ranges, this is a big trade show center, big conference area. So you see here, I'm going to fast forward this a little bit. I'm going to run all the way to the other side. This is like football fields long and wide, and it's still detecting, tracking, and classifying me all the way on the other side of this conference center, all the way. And it's going to be able to continuously be able to send data directly to the system to continuously track me in that environment. Now, I get asked all the time about obstructions, be it walls, signs, signage, whatever it may be. This is a big venue. We're actually tracking about 150,000 square feet with about 10 sensors. You can tell where the sensors are at right here. You can tell by the green and red, green and red, green and red, and they're all fused together. Now, what you'll see here is that we can pan and tilt and zoom around all throughout that 3D space. Now, regardless of the fact that there's walls, there's signage hanging down, or there's lights hanging, or whatever it may be, we can see on both sides of this environment. So if there's obstructions, we'll still be able to track where people are going in and out of hallways, where they're getting behind a sign, or they're being obstructed by some sort of blockage in that scene. We'll be able to detect and track and classify all throughout, as long as you fuse all the sensors together. So once again, that's a sensor fusion we're able to do. Now, in this environment, if you do have those event zones, if someone goes in an area where they shouldn't be, maybe it's an employee area, maybe it's a data center closet, whatever it may be, you can then trigger the cameras to then start tracking and slowing a queue into the zone that you need them to track. Now, setup overview before I go into NX. So the way this is done, you set up your 3D zones inside of NX. Then from there, you go into Qortex. And what you can then do right here is basically set up, well, first off, the Qortex API will then talk to the NX API. So you're going to configure the HTTP events and actions inside of Qortex. And then the event data, based on the event zones, the detections will then get pushed directly into NX. So we configure our zones, we configure our endpoint, and then from here, you go directly into NX and you configure your events. So we select generic event and the type of action. So let's go into a quick product demo. I'll show you what it looks like inside of NX. All right, so let me move.
Just real quick, while you're doing that, I got one more poll to share. I'm gonna launch this for a second. You guys answer this while Gerald's getting set up.
All right. Perfect. So what you're going to see is on the left-hand side is Qortex, and on the right is my NX server. Oh, are we ready, Tony? My bad.
Almost. 50% of people have voted. 60%. 70%. Getting on it. All right, I'm gonna close it out at 70%. So 29% said yes, they got a project right now that they think they can use this on. 57% said possibly, I'm gonna think about it, and 14% said no.
Okay. Great, Paul. Good stuff. Well, you guys don't know how to get a hold of us here momentarily. I'll show you how we work and how we deal directly to the channel. So first and foremost, on the left-hand side, once again, no smoke and mirrors, is me. Sit in my chair, you see the 3D zone, you see me moving around. On the right-hand side is my live system. My camera is pointed directly at me over here. And then what you're gonna see here is I've created the 3D zone. So I'm gonna basically scooch back in my chair and I'm gonna breach zone number 2. Now, before I do that, I want to show you inside of my rules section. I've created the rules in here to basically to push directly into my NX instance, as you can see right here. So basically, anytime I enter the 3D zone, it's going to push, and then whenever I exit, it's going to push to this endpoint as well. So that's what you're going to see here momentarily. So first and foremost, I'm going to go ahead and set up on NX to do a couple of things. So I'm going to go ahead and first off, I'm going to start my recording so I could create some bookmarks as well. So I'm going to enable that, click apply, click OK. I'm going to go into my event rules, and then I've already created several generic events. So right here, I'm going to show text overlay. It's going to say breach. It's going to execute a PTZ preset, which is going to move to Mr. Roboto back there in a minute. We also have execute PTZ. When I exit the 3D zone, it's going to move the camera back to an event zone. It's going to create a bookmark and show a text overlay, all in sequence. So this is all going to happen all at the same time as soon as you see me scooch back in my chair. So pay attention to the video on the right, and then I'm going to start scooching it back. So you can see right there, camera moves into Mr. Roboto. I'm in the 3D zone. I'm going to come back into the frame and move the camera back. You see the text overlay. If I go back into my bookmarks, you see the videos are actually getting bookmarked. If I go into the timeline, you can then see the bookmarks will then start getting added directly in here, which you can then play, add more notes, whatever you see fit. And then obviously if you're going into the notifications, you're getting the live notifications coming in as they pop up. Inside the alarm events, you get obviously all the historical events that occurred all throughout the property. But as you can see, pretty straightforward. It's very easy to set up. I mean, it's you know, I did this here within a matter of within about 30 minutes or so. I set up these zones. As you can see, you could create any number of zones inside of Qortex, and then once you create your generic events inside of NX, you can then start creating all kinds of different actions within the software. So that being said, I'm going to go back to the slides. So how do you buy this? How do we sell this? How do we support this? So we don't sell directly to the end user. We typically deal directly through systems integrators and distributors around the world. And as you can see here, these are some of our partners that we do sell with. You might see some familiar names on the slide. We are a global company though, so we do support a lot of our systems integration partners directly. We do offer professional services as well when required on very high-end, very difficult type of deployments. When it's hundreds and hundreds of sensors, we could come in for pro services. And we do have offices all throughout the EMEAs, APAC, the US. We are headquartered in Northern California in Sunnyvale. So we can definitely support you guys on any of your initiatives all throughout the world in that regard. So with that being said, now we got about just shy of 8 minutes or so. I'm going to open up for some Q&A. And I'll leave my contact information here on the slides as well. And there's no questions. Maybe me and you could talk for a bit here, Tony, if you have any additional questions.
Yeah. What's like an entry point for like a cost for like an MSRP for like, let's say a customer, small application, right? Has a one of the integrators has a great idea. They need one of these LiDAR sensors for like let's say a high value room or something like that with a cache area. Like, what is an entry point in terms of like a cost basis for like an end user for like a single sensor type system?
Yeah, absolutely. So don't quote me on pricing. I'm not a sales guy, but I will say that our MSRPs do range anywhere from 10 to 15,000 or so on sensors, but it really depends on the type of sensor: indoor, outdoor, 2D,
Yeah.
3D. You know, there's a lot of different caveats that come into play.
Sure.
With that being
And
said,
then,
there's also a software license as well that comes with it. And that can be perpetual, or that can also be on a yearly basis. It really depends on how the customer wants to
yearly
buy
SaaS
it.
basis. Yeah. What's the warranty on like one of these sensors? How long do they last?
Yeah, so our sensors are off the shelf, 2 years warranty, which is a pretty good for the LiDAR industry. In fact, I think we're the only ones that are doing 2 years off the shelf. Then we also offer an additional 3 years that you can buy to add on, so giving you a total of 5 years of coverage on the sensor.
Well, yeah, just because it spends so much, it's like PTZ cameras. I mean, like when I was younger, man, PTZ camera was a dicey thing to put in place because it was going to eventually have some problems, and you're going to have to deal with the customer on it. with LiDAR, I mean, it's constantly spinning, right? So it's not as much of a, I think, a concern, right? But it is a moving part in a device, right? So that's why I was curious about the duration of
It's a
these
good
things from the
question.
lifetime.
If there is any main point that would be a failure, would be that actually it's spinning on a turret, right? So it's on a bearing, right? So that's probably the primary source of any potential RMA that would ever occur. But in essence,
But they are super low power, right?
yeah, and we've had these sensors also deployed for years at very difficult environments. I mean, 140-degree weather, sandstorms, raining, and
Yeah,
all
I mean
kinds of
everybody
crazy
knows that the warranty isn't related to the actual MTBF so much, right? It's more about the commitments of the product from a manufacturer side, right?
Absolutely.
So no questions still. Oh, there's a question. If I search Quanergy in the industry website, nothing comes up.
Yeah, so we're working with Annixter right now on T's and C's. We're in the middle of working through some global agreements. But in essence, if you reach out to Annixter, you'll be able to get pricing from them.
All right. Another one is, can you share details on the optical phased array devices?
Yeah, so our OPA sensor is basically a no moving part sensor, and then basically what it is, we steer the laser beams within the optical phase array to be able to move around and be able to track that environment. It is a 2D sensor. It's predominantly used more in other industries like robotics, industrial, and stuff like that. From the perspective of a physical security application, it could potentially be used for like counting as people enter and exit, but it's
Right.
got very limited use in that regard. Our flagship sensor is probably the one that has the most applications in what it can do. And it's the one sensor that's most widely integrated in industry, where it's very limited integration with the OPA.
So a 2D sensor, LiDAR sensor, is basically going to be like an advanced IR curtain. Is that right? It's like
But
basically like, you know how like in like Star Trek you get like the force field like jail cells, right? But you can tell, like, basically you're saying you can tell with an IR curtain you can tell somebody broke the beam, right?
yes,
With a 2D sensor you can tell where they broke the beam and how much they went, what came through basically, right? At what point is the way
yeah,
I'm visualizing it.
that's it.
So, I
That's the way
can't
to
I
look.
can't think of a lot of very specific security applications for that because of the nature of it. It's basically an IR sensor at that point, right? I mean, an
That's what
advanced IR
it is.
sensor.
Yeah, that's what it is. And that's why I'm saying that there's probably other industries that benefit more from that. When you put this on AGV or going down warehouses to count product on shelves and stuff like that, that's where that
Like
sensor really.
production monitoring, QAing specific devices and stuff like that, where you need to look at one side of it. Like I get that, yeah.
Mhm.
What's the infrared range? Is the question.
So, I mean, the range of the sensor in itself is it can shoot out to 200 meters in diameter, right? So, you're going to be able to detect objects quite a long distance. Now, as I mentioned earlier, we do tell people that to do continuous tracking classification and all that, we say it's 140 meters of continuous, just because we
Diameter.
all,
So 70 to 100 meters basically radius.
yeah,
So
exactly.
if you're putting the point, if you're trying to measure 140-meter area, you're gonna put that sucker right in the middle, basically, right?
Yep. Yeah, the one thing I do need to highlight is that there is a blind spot directly below.
Okay.
So we're not shooting the lasers down, so it creates this circle, or like we call it a donut, if you will, that basically a blind
The
spot.
halo. Yeah.
Yeah, halo that's directly below. But when you overlap them, you get that continuous tracking. But in most cases, if anyone's already gotten to the center of the sensor, then your security practice has been broken already, right? So it's a
Right.
matter of understanding, where the blind spots are, where the potential gaps are, making sure you have enough sensor coverage to overlap. And in that regard, you shouldn't have any issues. And once again, that's how we maintain such a high degree of accuracy in tracking objects.
Raymond wants to know, can you mount it upside down from like a pole or a ceiling in that case if you're getting a blind spot there?
No, not necessarily. So these sensors, this current version is not meant to be mounted upside down. We have clients that do mount them on various angles. They can mount them at various angles, but it's typically, I mean, this is the heat sink right here, and it's mounted on a turret right here, and it's spinning circles. So you flip it upside down. It's probably not good for the livelihood of the sensor itself. So probably shorten that out. But we've seen people have done it, but we don't recommend it. It's not. It's just not the way it's meant to operate.
Yeah, I hear you. Any other question?
We're right at the mark too, so we got 10
Yeah,
seconds. Tony, I
10,
appreciate you having us.
9, 8. No, I'm just kidding. Yeah, guys. Well, this information is all up on the website right now. Our website, the Quanergy Works with the Next listing. It's also available in the integrations marketplace at nxvms.com if you want to take a look at it. So Gerald's contact information should be available on both in the Quanergy website. If you have any questions, right? As you can see, it's pretty cool, right? I mean, like you can do some really interesting stuff. Some of the use cases that we've discussed with clients, and some of the clients are already doing this stuff, especially like logistics and warehousing. Um, being able to track where forklifts are in relation to people, so that you don't have forklifts going through speed doors or running into people, right? Basically, health and safety application, as well as the security side of the application as well. It's a situational awareness tool. Um, that's what video ultimately is. Traditionally it's been an event review technology, with the kind of onslaught of computer vision applications and things like Quanergy's LiDAR. Now we're turning video into a kind of proactive tool for like real-time management of facilities and situations that are occurring out there. So it's not something that I personally have traditionally thought about until I saw what these guys did with our integration, and I was like, oh crap, like there's a lot of things that we can do here, right? So I'm really interested to see, like in the poll we had 86% of you guys who say I think I can use this, right? So it's a pretty good indication that there's something here. My suggestion is you guys go out and get familiar with this and see if you got some applications. The integration itself is great. The PTZ tracking stuff is really cool. Um, so, thanks, Gerald, for coming on and explaining it to us, showing us how it works.
Yeah,
And
absolutely.
thank you guys for coming to this Works for the Next webinar. And we'll see you at the next one. All right.
Thanks, everybody.
Thank you, everybody. Have a good one.